Hi students, in previous class we saw about A to D and D to A interface, and let us recollect about it. We use 8255 chip to interface with 8085 and 8086 microprocessor. So here in which you use port A of 8255 is used as an input port, and also the pin PC7 pin for port C upper is connected to the end of conversion pin of analog to digital converter, and this port also used as an input port, and the PC22 that is 0 to 7, so 2 to 0 lines are connected to three address pins of the chips to select the input signal, where the pin 3 connected to pin 6 is connected to start of conversion. And now let us discuss about the program. Okay, so here move a comma 98H represent set port A as upper as input and C lower as output, and out CWR comma AL is to write control word to the control register, and next is your move AL comma 0 to H is to select P2 as an analog input. Next is your output port B comma AL is port B as an output. Next move AL comma 0 H is get start of conversion pulse to ADC, whereas output port C is comma AL is port B as an output, and move AL comma 01 is end of conversion. Next give end of conversion pulse to the start of conversion pulse to the ADC, and next output C, that is whenever you get a value you need to check successively with the value which is initialized. So until it reached the maximum value you have to keep on continuously make monitoring of the system. So until you need to wait until it reaches a defined level. So here IN AL comma port C is check the end of conversion by reading the port C as upper. Next is RCL is for to carry, and JNC is for if jump no carry. So if there is no carry, so IN AL comma port A, then it provides an end of conversion pulse. It reads a digital equivalent of analog converter signal. So next is your halt, that is end of the program. So this is your block diagram of interfacing 0808 to 8086 through 8255. So here you have a P0 to PC0 to PC7. PC0 is for start of conversion, PC7 is for end of conversion, where PA0 to PA7 is your address pins, and P2 is an analog input voltage. Then there is a clock up, and PB0 is connected to A, PB1 is connected to P, and PB2 is connected to C. And you also have similarly to that controller you have same read and write operations and reset, and D0 to D7. So interfacing of a digital to analog converter. So the digital to analog converter converts the binary numbers into analog equivalent voltage. So the DAC finds application areas like digitally controlled gains, motor speed control, programmable gain amplifiers. Okay, so here they use AD7523, an 8-bit multiplying DAC. It has a 16-bit DIP, and here they have a digital to analog converter containing R to R ladder for converting an analog conversion. So here the power supply is plus volt to plus 15 volt, and the reference voltage is to from minus 10 volt to plus 10 volt. The maximum analog output voltage will be plus 10 volt, and a zener is connected between out 1 to out 2 to save the DAC for negative transients. Then the op amp is used as a current to voltage converter at the output of AD7523, and an external feedback resistor acts to control the gain. So this is the interfacing of AD7253 with AD86. Here is a problem that interface a DAC AD7523 with AD86 running at 8 MHz. Write a program to generate a sawtooth waveform of a period of 1 microsecond, that is maximum voltage is 5 volt. So here move AL, 080H is you are moving the value of 80H to the accumulator. Next is your out CW, AL is to write the control word to the 8255, 7523, and move AL, 00H is similar to that. You are initializing the accumulator, then back to output port A, AL. So here you are valuing the moving the accumulator value to A. Next JB back. Next is your JMP again, that is your jump signal and end of program. So this is your pin diagram of AD7523, where your 1 and 2 is connected to output 1 and 2, and third pin is connected to ground, and so your 4 to 8 pin is connected to MSB of B1 to B5, and 15th is connected to the reference voltages, and 14th pin is connected to the supply voltage, and 13th and 12th pin is no connection, and your 10th and 9th pin is connected to LSB of B6 and B7. Next, this is the interfacing connection of AD7523 with the 8086 microprocessor, and it is connected with the help of op-amp, and so here the interfacing an 8255 with 8086 at 80H as an input output port of port A, interface 5 segment display with 8255, and this is the sequence of instruction to display, and this is the interface connection multiplex between 7 segment display through 8255, and this is a program for ALP for display interface. So here move CL, 05H is count for display, and move BX, 2000 is initializing a data segment, and next one is your lookup table initialization, and next this number to be displayed. So here out 86, AL is load control word in CWR, and DL, ONH is to enable the code for least significant 7 segment display, and here move BX, to set a pointer to the lookup table, and move AL, CH to store the number to the display, and X to find from the code from the table, and out 80 and 82H is enable the display, and ROLDL to go to the next digital to the display, and increment and decrement counter, then jump J and Z is the jump to go for a next digit display. So with this we conclude A to T and D to A interfacing, and in next class we see about what is step-up mode of interface. Okay, thank you, have a nice day.